G'day guys, welcome back to the shed. I'm BC. Today I've got a couple of 3 flute countersinks to grind, so I thought I'd bring you along and give you a bit of a look inside the workings of the radial and relief grinding attachment, and I'll do a bit of that with the motors turned off so we can get a bit better audio. So turn the camera off and move you around. Here we have the electric speed control box. Very basic machine. It's got a 240 to 110 transformer and just a little variac on the front. The motor itself is made by Precision Gears in America. A little 110 volt DC motor, timing belt drive on the side with a tensioning lever, so make it drive and back it off when you want to turn the spindle freely to align the cutter. And I think that's why it lasted so long and did such a good job. It's just such a simple bit of machinery, very, very good for doing the job. Now down the bottom, I've said this once before, but I've got another inquiry. This adjusting knob here allows you to lock up one of the axes of the grinder. The grinder has 2 V-ways inside that mounting block with little V-shaped rollers that run in them, and they encase that all in elastometric material. I think it's just a rubber, and that allows you to lock off one direction of axis so it doesn't rock sideways. It only has a forward and aft pecking motion, and that gives you the actual relief behind the cutting edge. Move even closer and look more at the drive mechanism. Here's another look at the back end of the drive mechanism. The hand wheel is actually the shaft nut to draw everything up tight. There's the cam, and the cam can be reversed for left hand thread. The mechanism that does the clearance action work is mounted on a dovetail block, and you can release the clamp block to move it out to change the cam. It has a latching lever in here so you can block off one part of the action as well as use the nut down the bottom. Very sturdily built, very little wear on any of it despite its age. Everything is absolutely rock hard. So I'll move the camera again and bring him on the cam gear. I've got the attachment running now. I'll try and get in a little closer. And we are still focused there. So you can see the cam pushes against the roller on the right hand side of the mechanism. This is the rocker shaft about the pivot point, and you can change the pivot point to change the ratio of axial and radial relief. I've got it set in the middle now. So the cam works on the right hand roller, pivots about the bolt, and then uses the left hand roller to push the whole body of the attachment backwards and forwards to get the actual relief. So very, very simple. So far it's lasted about 60 years. I think it's only got another 160 left in it if I don't neglect the machine. And we'll back out again. And you should just be able to discern the whole head moving backwards and forwards. Now it's got 2 holes through the body here, and there is actually a tailstock you can mount that's about 18 inches long with a little dead centre in the back end for doing very, very long cutters like enormous taps, etc. So the scope of what you can grind with this is fairly well limitless, and it does a damn good job. Very good value for money. Okay, I'll get the countersink mounted up and we can have a look at some sparks coming off it. Just a bit of an aside here for all you guys that want to make your own adjustable table stops for a tool and cutter grinder. That's the stop built up by an employee of mine years ago. Just a simple bit of angle iron with a bracket and a plate welded onto it, and this is the adjustable stop. Fine thread bolt, probably 24 TPI, gives you very, very fine adjustments, and a handy way to make it. Simple, and it's just a T-bolt inside the slot that it's attached to. So I don't think tool and cutter attachments have to be mind-boggling. Something as simple as that is easy to make and really adds to the usefulness of the machine for a lot of operations. Okay, setting up the cutter to align it to the cam. On the left-hand side we have a gauge plate, bit of homemade plate, drops into the slot closest to the lobe of the cam. That aligns the cam to the starting point. We put the cutter in the chuck and we aligned the leading and trailing edge of the flute at the back with a straight edge and a square. And the straight edge is just an indexing plate for the turn cutter grinder, and a machinist square. So come in from the back, rotate the cutter until the front and rear edges of the flute are in line, unlock the spindle, turn it around till you get to the locking point and tighten up the chuck. And usually that gets it concentric within 1 or 2 thou, and with the trailing and leading edge of the flute aligned vertically at the back. That seems to be, as per the instructions in the book, and that seems to work the best. So I'll get it finished and we'll start up and grind. Okay, we've got the cutter running now. I'll turn on my phase converter, and I'm sorry that the audio will disappear a bit, but I can't have it both ways, and then we'll start some grinding. That fell down. And all I do is I crack it in a thou at a time, and then on the tool back in front of the wheel. And another thou. I don't take it in much as it's a fairly rigid setup, and I would hate to crash it. No, still up. Ah, here we go. There's one flute being ground. Second one. Now I don't use a collet because all of the collets for the front of the shaft are fairly badly worn, and they're a Royal Oak special paper and extremely expensive. But being a thou or two out on the flutes doesn't really matter. They still come up nice and sharp. The customer uses these countersinks on stainless steel, and he's smart enough to take them out of service before they're completely buggered. It's just starting to grind on the back of the land now. Another thou. And again. And we got the third one coming up. So I'd say we're about 3 thou out of concentricity, and for a cutter like this, that's nothing. Now the wheel I'm using is a white aluminium oxide 9A, and it's a 46 grit. I use it because that's what I had in stock at the time, but also with the small number of grains contacting the work, less heat is generated. Now, these cutters get very, very hot. You get a very good finish because the depth of the scratches or striations is controlled by how far the grain is impinged on the wheel. So I go in another thou. think it'll be one more hour and the cutter will be cleaned up. No, a little bit more. And once again, I think this should have it. And that's it. The cutter is cleaned up quite nicely behind the cutting edges, and as you pull it out of the surface just as it started to get blunt, that should be good to go. Once you've got it set up, just a couple of minutes, and yes, the grinder is still a bit of a pig. Haven't cleaned it up since the last episode. Okay, that's it for now. Please like and subscribe.